Hi viewers, welcome to my class on mechanics of materials. In today's class, I'll continue to work out some more numerical examples which were a part of the GATE question papers in the past related to this topic. Let us start with the first example. Consider a step shaft subjected to a twisting moment applied at B as shown in figure. Assume shear modulus G is equal to 77 gigapascal. What is the angle of twist at C in degrees? Now it's a stepped shaft with the diameter here 20 mm and one more section with a diameter 10 mm. Both the sections are 500 mm long. It is subjected to a torque 10 Newton meter at point B, at the junction B. Now you have to find out the angle of twist at C. So this part is subjected to a torque 10 Newton meter. It is fixed at A and subjected to torque at B. Now if you take this section, the torque acting in this section is 10 Newton meter. There is no other torque, only one torque is acting. So at this section, torque is 10 Newton meter. But in the section BC, somewhere if you take a section plane and consider the right portion, there is no torque at all. So BC, the section BC is not subjected to any torque, or torque acting in the section BC is equal to 0. So only section AB is subjected to torque and the magnitude of torque is 10 Newton meter. Now you have to find out the angular twist at C. Angular twist at C is angular twist in the section AB plus angular twist in the section BC. So angular twist at BC is 0 because there is no torque in the section BC. Only you have to find out the angular twist in the section AB, and which will give the angle of twist at C. So only you have to find out the angle of twist for the section AB, which will give the angle of twist at C. So T1 is 10 Newton meter, which is equal to 10 into 10 raised to 3 Newton mm. And T2 is 0. The torque in the section T2 is 0. Theta is equal to theta 1 plus theta 2. And since theta 2 is 0, it's equal to theta 1. And theta, the angular twist is given by TL by Jg. So TL divided by solid circular shaft, it is 5 by 32 T to the power of 4 into G, or 32 TL divided by 5D to the power of 4G. Now substituting for torque 10 Newton meter or 10 into 10 raised to 3, and length is 500 and diameter is 20 for this section, and modulus of rigidity is given as 77 gigapascal or 77 into 10 raised to 3, which will work out to 0.00413 radian. And converting into degrees, you can multiply this with the 180 by pi, which will give 0.237 degree. So that will be the angular twist at the NC with respect to fixed and A. Now let us work out another example. Two solid circular shafts of R1 and R2 are subjected to same torque. The maximum shear stresses developed in the two shafts are τ1 and τ2. If R1 by R2 is equal to 2, then what is the ratio τ1 by τ2? We know the maximum shear stress in a solid circular shaft is given by 16T by pi d cube. So in terms of R, it is if you substitute d as 2R, that will be 8R cube, and 8 will cancel in 16 2 times. So 2T by pi R cube, that will be the maximum shear stress in terms of radius. So τ1 by τ2, the ratio of shear stresses induced in two shafts of radius R1 and R2, you can find out as 2T divided by pi R1 cube divided by 2T divided by pi R2 cube. The torques are same torques are acting, so radius are R1 and R2. So when torques are same, it is R2 by R1 cube. τ1 by τ2 is R2 by R1 cube. R2 by R1, we know R1 by R2 is given as 2, so R2 by R1 is 1 by 2. So 1 by 2 cube, or it is 1 by 8. So tau 1 by tau 2 will be 1 by 8 when R1 by R2 is equal to 2. So the shear stress induced is inversely proportional to the cube of the radius. Inversely proportional to the cube of the radius. Say R1 by R2 is equal to 2, then tau 2 by tau 1 would have been 8 because it is inversely proportional to the cube of the radius. So if it is R1 by R2 is 2, tau 2 by tau 1 will be 8, 2 to the power of 3. If R1 by R2 is equal to 3, tau 2 by tau 1 will be 3 cube or 27, but tau 1 by tau 2 will be 1 by 27. Now let us work out another question. A rope brake dynamometer attached to the crankshaft of an IC engine measures a brake power of 10 kilowatt when the speed of rotation of the shaft is 400 radians per second. What is the shaft torque in Newton meter sensed by the dynamometer? We know the power is given by torque into angular velocity, or torque is power by angular velocity. Power transmitted, we know 10 kilowatt or 10 into 1000 watts or Newton meter per second. So we are getting the power transmitted in watts. Okay, power transmitted, we have converted from kilowatt to watts, divided by angular velocity is directly given. Angular rotation is 400 radians per second. This in 1 second it rotates by 400 radians. So this is nothing but the angular velocity omega. So its angular velocity is 400. So you get 25 Newton meter as the torque transmitted by the shaft. Let us work out another example. A rigid horizontal rod of length 2L is fixed to a circular cylinder of radius r as shown in the figure. Vertical forces of magnitude P are applied at the two ends as shown in the figure. The shear modulus for the cylinder is G and the Young's modulus is E. What is the vertical deflection at point A? This is a cylinder which is fixed here, and another horizontal rod is attached at the other end. The cylinder is having a radius r, and this horizontal rod, the length is 2L, and it's subjected to forces like this. The magnitude of the forces is P. Now these vertical forces will produce a torque on the cylinder because the rod is attached to the cylinder firmly. So this forces applied, this will form a couple or torque. It will produce a torque, and the torque produced is P into 2L. The force into 2L, the distance between, that is the torque produced by the forces on the cylinder. So you can find out the torque as P into 2L. So torque is P into 2L. Now as a result of the torque, the angular rotation undergone by the cylinder is TL by Jg. J is for a solid circular cylinder, it is pi by 32 d to the power of 4. So TL by Jg, J is replaced by polar moment of inertia of the circular cross section, that is pi by 32 d to the power of 4. Now you will get 32, that is 32 TL. 32 I have taken to the numerator. 32 into T is 2PL. 2PL into length. So 2PL is the torque into length divided by pi d to the power of 4. D is 2r, in terms of radius, 2r to the power of 4 into G. So you get 2 to the power of 4 is 16. So if you cancel 16 in 32, you get 2 into 2, 4 PL square divided by pi r raised to 4G. So that will be the angular rotation of this cylinder at the end. So it will rotate by an angle so much at the end. So as the rod is also firmly fixed, this rod also will undergo a rotation by an angle theta. So the same angle this rod also rotates. So this end will rotate and it will take a shape like this. So this will be the angle of rotation. This angle of rotation is calculated. So as a result of this angle of rotation, this end A will move by a small distance. So the distance moved you can calculate as this angle through which it rotates multiplied by length. This radius, this is fixed at the center here. Okay, with respect to this point it is rotating. So the radius of this rod is L. L into the angle through which it rotates will give the movement of this end A. So deflection at A is the theta into L. So which gives 4 PLQ divided by pi r raised to 4g. So that is the vertical movement of vertical deflection at point A. Let us work out another question. A machine frame shown in the figure below is subjected to a horizontal force 600 Newton parallel to Z direction. What is the normal and shear stresses in megapascal at point P? So this is a machine frame. It's subjected to 600 Newton force which is parallel to Z direction. So this is Z direction, X, Z and Y direction. So parallel to Z axis, force is acting at the end of this frame. Now this frame will produce some twisting with respect to point P. So it is fixed here that this is a rod with a circular cross section. So since it is fixed here, this force will try to rotate the rod. So this moment acting or torque acting you can find out as 600 into 500. So that will be the torque acting on this shaft. So if you take this as a shaft, so 600 will produce a rotation and this torque 600 Newton into 500 mm will be the torque acting at point P. So this force is producing a torque at P and also it's producing a bending due to this distance, and the distance from the point P to this force is 300 mm. So this 600 into 300 will be the moment acting at P. So it is also trying to bend this shaft. So not only the producing a torque, it is also trying to bend the shaft. So this 600 Newton force is also trying to bend the rod, and the bending moment acting is 600 into this distance from the point P. Okay, 600 into 300, that will be the bending moment acting at P. So this force will have two effects. One is a torque. It will produce a torque of 600 Newton into 500 mm, and also it will produce a bending moment 600 Newton into 300 mm. So that will be bending moment. Now you can find out the maximum shear stress due to a torque as 16T divided by pi dq. We know the torque acting at this point P due to this force 600 into 500. So that will be the torque in Newton mm. So torque in Newton mm is 600 into 500 divided by pi dq. D is diameter of this is 30 mm. So pi dq, which will give the shear stress due to this force at this point P on the surface of this rod. So maximum shear stress on the rod at point P will be 56.59 Newton per mm square. So that is the maximum shear stress at point P. Now to find out the normal stress or bending stress induced as a result of this force, you can use the bending equation M by I is equal to sigma max by Y max, or M is equal to I by Y max into sigma max I moment of inertia of this circular cross section is pi d to the power of 4 by 64 divided by maximum distance from the center to the outermost fiber is d by 2. So you get pi d cube by 32 into sigma max. So that is m. M is pi by 32 d cube into sigma max. Pi by 32 d cube into sigma max, or sigma max is 32 m by pi d cube. So maximum stress induced on the surface due to bending can be found out as 32 m by pi d cube. This is for a solid circular shaft. The bending stress induced due to a bending moment m is 32 m by pi d cube. This will be the maximum bending stress induced. So 32 into, the bending moment is 600 into 300, 600 Newton into 300 mm. So 32 into 600 into 300 divided by pi into diameter is 30 cube, which will give the maximum stress induced as 67.9 Newton per mm square. So this is a normal stress or bending stress induced at point P. So at point P, there are two stresses. One is the normal stress 67.9 Newton per mm square, and another shear stress of magnitude 56.59 Newton per mm square. Apart from this, a direct shear stress also will be induced, which can be calculated as 600 divided by area of cross section, and that is going to be a meager value when compared to the shear stress introduced by this torque and bending stress induced due to this force. Now let us work out another example. Two shafts A and B are made of same material. The diameter of shaft B is twice that of shaft A. What is the ratio of power transmitted by shaft A to that of shaft B? TA is the torque transmitted by a shaft is given by pi by 16 d cube into tau max. So for shaft A, you can find out TA as pi by 16 di cube into tau max. Since the materials are same, maximum shear stress is, I'll put it as tau max. Therefore, material A, for the shaft A, torque transmitted is TA, diameter is dA. Now for the shaft B, the torque transmitted by that shaft is pi by 16 dV cube into tau max. So tau max is same, okay. Because power is directly proportional to torque, ratio of power transmitted is equal to the ratio of torque transmitted. So power is given by 2 pi nt divided by 60,000. So power is directly proportional to the torque. So ratio of power transmitted means ratio of torque transmitted. So the ratio of torque transmitted is TA by TB. And if you take TA by TB, tau max will cancel because materials are same, maximum shear stress remains same. So that will cancel and you get dA cube by dB cube or dA by dB cube. So that is the ratio of torque transmitted or ratio of power transmitted. So now dA by dB, we know the diameter of B is twice of that of A. So dA by dB is 1 by 2 cube or 1 by 8. So the ratio of power transmitted the shaft A to B is 1 by 8. So power transmitted is directly proportional to the cube of the diameter or cube of radius. Directly you can take the ratio is 2, the diameter ratio is 2, diameter of shaft B is twice that of A. So dB by dA is 2. You can immediately get the ratio of power transmitted for the shaft A to that of B is 1 by 8. That's all for today. Thank you for watching.